Hi guys, so welcome to week 5 in class practice. So I'll be covering week 5 in class practice content here. And just like last week's, I'm going to work on the Excel sheet. So let me share my screen. So I hope by now you guys know how to access the in-class practice. Um, You can go to the website, course website, and under assignments, in-class practice and access the in-class practice by week here. And you can find the weekly in-class practices. So this is week 5. This is the question, the data set and the question. And as always, I'll be working on the in-class key, which has the key at the answers, and how to do all of it. So I'll be working on that. So basically, the data, if you see the data here, it's concerned with military expenditures in different countries across from 2013 to 2022, and the military expenditure. So right now, the data that you need to be concerned with is like the first four columns, the country, region, year, and military expenditure. In this practice, we won't be using the rest of the three columns or disregard them for right now. And so, yeah, so military expenditure across different countries across 10 years. And so this is what we'll be working with. So let's get into the questions. Um, so if you see here, the first is calculate the minimum, maximum, mean, and standard deviation of military expenditures in constant 2021 USD military for each country in sheet country stats. So basically, what we need to do is we need to find the minimum, maximum, mean, and this is very similar to week 4 practice where we made a pivot table to calculate these numbers. Um, so what you need to do is select all the data in the first four columns. Um, and then we can insert a pivot table um, in a new sheet. So what we need is we need the country, which will go into the rows. So each country, right? And now we need the minimum, maximum, average, and standard deviation. If you remember class 4, um, week 4 practice, you just need to put whatever you need the minimum, maximum, or values of into the values column, into the values field. So we want the military expenditure. So if you put it here, it's going to default to the sum. We don't want the default. We don't want the sum. Um, we want the minimum, and it's going to find the minimum across the 10 years. And then we want the maximum. So again, you repeat the process and we want the maximum. Um, and we want the average. So again, you put that and you change sum to average. And finally, you need the standard deviation. And here is the standard deviation. So um, this is how you get these summary statistics, and it's a very neat and quick way to get these summary statistics. Um, so you put these in value, and so you get these summary statistics for each country. It's going to find the average across those 10 years. It's going to find the maximum between those 10 years, and it's going to find the standard deviation. And you can also convert like standard deviation into currency. So you just select the currency here and it's going to convert that. So that is pretty much question 1. You just need that, and country stat sheet is already here. So this is the key, um, right? Um, I need to remove this. Created this earlier. Right. So the next question is, what are the lowest and highest 10-year averages of military expenditures? So you can do it two different ways. The first is you can find you can do the minimum and maximum function, but the other thing you can do is if you go to your pivot table, and so you want the minimum and maximum of average, this column, right? So if you go here, you can sort. And if you come here in the rows country, it's going to ask you how do you want to sort it. So you don't want to sort it by, it's right now sorted by country and from A to Z, but you want to sort it on the average of military expenditure. So you select the column here, average of military expenditure and ascending. So your lowest is $0, and it's for three countries, Costa Rica, Iceland, and Panama. And then if you do the descending, you'll find that the highest average military expenditure is for United States of America. So that's your other answer. Um, the lowest is 0 for Costa Rica, Iceland, Panama, and highest for US. Okay, so next question is randomly selecting a country from this list. What is the probability of selecting one with the military expenditure higher than 50 billion? So basically, what it's asking is that you have this probability distribution function where you have like this normal distribution function, right? Which has like a normal distribution curve. So our data also has this distribution. So we what we want to do is we first want to um, build that distribution, and then within that we say, okay, if we get a value of 50 billion, then what is the probability that we get that if we select randomly from that distribution, that's what's the probability that we get something greater than 50 billion. Um, and so for that, what you can do is there's an Excel formula, and it's given here. So it's normal distribution. So what it will do is you can use the normal distribution function, and you can read more about it here. Basically, what it does is it creates that distribution that it assumes uh, that our data has normal distribution, and from that, if you give it a value, uh, and given a mean and standard deviation, which is the mean and standard deviation of our distribution, it is going to find the probability. Now, obviously, this is assuming that our data has normal distribution. It's not always true. Our data might not have normal distribution, but to make the best guess for that probability, you're going to assume normal distribution because that makes it easier to find the probability, because then otherwise it's very difficult to find the probability. So what we're going to feed into this normal distribution formula is you are going to give it uh, what is the value that you want to find the probability at, which is the 50 billion. um, what is the mean of the distribution, what is the standard deviation of the distribution, and finally true and false. True is for cumulative distribution. So if you remember from the statistics class, our normal distribution curve, it has two sides, right? At the middle, it's the mean, and on the right side and the left side. So it can give you probability on both sides, or if you do the cumulative, so it starts from the left and starts moving to the extreme right. So we want the probability, so that's why we want to consider both the sides, and we want to start from the left side. So we're going to select true because we want the cumulative distribution function. So um and so maybe I think it's good to show you guys normal distribution, cumulative. So, like this is what we are doing. We are trying to find the probability. And this is our sort of what normal distribution looks like. So we're trying to find, let's say this is 50 billion, then what's the probability of getting something more than 50 billion? So we're trying to find this white space, the probability. Um, yeah. So what we're going to do is we're going to find that probability, and as you said, the formula is that you need to have so normal distribution, and you first give it the value that you want to find the probability at. So 50 billion, and 50 billion has 10 zeros. So just be careful about that. And so now we want to give it the mean of our distribution. So we are going to take that from our pivot table. If you go to the pivot table here, you have this average. And if you go to the grand total here at the end, this is the average of our distribution. So we are going to give it that. And we are going to give it a standard deviation, which is this. So this is the standard deviation column, and this is the standard deviation of our distribution. And we are going to say that it is true. Right. Now it is giving the probability of finding everything below 50,000, 50 billion, because that is how normal distribution gives you the probability. Because if you see here, it's going to give you that green area, but we want the white area. So it's simple that we just put one minus, and we are going to get this probability, and it's already done here. The other way is to, you can also specify get pivot data. There's other like, if you don't want to manually go and pick the data, you can also specify get pivot data, average of military expenditures, 2021, and country stats, and it's going to you can pick it from the grand total. So that's the other way, but I think this is the easier way, faster way. So I use this, but it's essentially doing the same thing. Both of them are doing the same thing. And so let's change the color here. Right. So that's your probability. Okay. And question number four. So we have generated a simple random sample of 10 countries. Calculate the minimum, maximum, mean, and standard deviation of the over the last 10 years for the entire sample and compare to those of the population data. So basically, in your data set, you had all these countries, right? Um, from Afghanistan to Zimbabwe, but now we have selected a sample of 10 countries. So you are going to do the same thing that you did for this creating this pivot table, but now you're going to apply a filter where you are going to have these countries, only these countries. You're just going to take the statistics of these 10 countries. So it's basically in the sample stats is done here. So what you'll do is you put the country in the rows, same as before, and you do the military, and you do the minimum, maximum, average, and standard deviation, right? And then you put in filters, you want to put the country because you're filtering by countries, right? So, and then once you have the filters, you select those 10 countries. So they are selected here. So it's Congo. So you see Congo is selected, Hungary. Um, and one easier way to do is like you can search for it, Hungary, and then so let's say if you wanted to put United States, sorry, let's say Turkey, you wanted to put Tunisia, sorry. So you would just click on Tunisia, right? And it will select it. So you can, that's a easier, faster way. So we have the 10 countries, and what we want to do is the question asks, okay, so, and compare to those of the population data, right? So this was your population data, and this was your minimum, maximum of the from the population, your average, and your standard deviation. And this is your sample. Your minimum, your uh, maximum, your average, and your standard deviation. So um, they have been set here. So this is your sample, right? So these are your sample summary statistics, and these are your population. And as you can imagine, The minimum is higher for samples because we don't have those countries which had like $0 minimum, so it depends randomly. Your maximum is higher for the population again because in your sample you don't have all those big countries like China or United States. Um, and average, as you would assume, it would be, lower for your sample. Um, but also it could be higher because let's say, if you pick the top 10 countries as your sample, then their average would be higher than your population. So it depends what your sample looks like. So this is a good indication, right? So this sample is lower and your standard deviation for a sample is lower. And that's usually true for samples because, you have less countries, so, you have less variability. But then again, you might pick uh, 10 countries which are all consecutively close to each other in terms of values, then your standard deviation would be very low, or you can pick like um, highly variable countries like the lowest and then the top one, and then somewhere in between, and the standard deviation might be higher than your population. So it all depends how you sample. Um, so yeah, so compared to population, the sample minimum is much higher, sample maximum is much lower, average is much lower, and standard deviation is much lower. And so the idea is that there's no set answer always that, this is all that the minimum or maximum will be always higher or lower than the population. It all depends on where you select the sample from and how you pick the sample. So these values can vary a lot. So this was how you do the sample statistics. So basically, you just put the pivot table and you put the filter of the countries and just copy paste these values and set them here and then compare those to your um, actual values, right? And then finally, so question number 5. Calculate the Z-score and percentiles for the 10-year average of military expenditures. So if you see this diagram, this is basically a Z-score diagram. So this is not actually writing the values. So you will come across two different type of diagrams here. For normal distribution, sometimes it revalues, but the other representation is Z values. And Z value basically is your so what is the Z value formula? So Z value is the the value that you want, the value that you have, minus the mean of the distribution divided by the standard deviation. It basically tells how far your value is, how many standard deviations far your value is from the your mean. So this is your mean, right? So this value is two standard deviations away. So basically it is two standard deviations away from the mean. And usually your usually how normal distributions work is within two um within your two standard deviations, 95% of your values will fall. So basically what the question is asking you to say is that, okay, calculate the Z value first and then tell the percentile, which is basically your okay, sort of like which is the probability basically of finding that value, right? What percentile does it fall? So like if you have the if second standard deviation that approximately 95 percentile, actually not 95 now, actually 97.5 percentile, and then yeah, so and then this mean is 50 percentile, obviously because it's split half. So that is what the question is asking. So if you go back to the question, so again, there are formulas for so not formula for Z score. So you want to calculate the Z scores yourself. And if you go here, they are calculated, but I'm going to show you. So basically, Z-score is what you want to get the value of your country. So in this case, you want to get the value of China, the average military expenditure of China in 10 years, minus the average military expenditure of your distribution of the whole countries, and divide that by the standard deviation of your distribution. So, what you can do is you can use the get pivot data formula. And for that formula, what you need to do is you need to first specify which column you want to pick from. So if we go here, and we'll have to give the name. So we want to pick from this average of military expenditure USD, right? And with Excel, one thing you want to make sure is that if your string has spaces, then you want to use these quotation marks. If they don't have spaces, then if they're continuous, like if it had like this underscore means it's continuous, then you can skip using this in some cases. But if there's a space, then you want to use that because then it will recognize that this is the whole name. Otherwise, if you give the space, it will recognize these separate values. So, what column you want to pick from? Um, and okay, and you and so what value do you want to pick from, and from which column do you want to pick from? And um, so you're going to basically give it the sorry you so first is what value do you want to pick from, and what is the range? Or so in this case, you will give it the sheet and the sheet name. So in this case, your sheet name is um, pivot table 2. Again, if you have the sheet name and it has um, spaces, then you want to use the single quotation marks. Pivot table, sorry, it was pivot table 2. Yes. And it's not capitalized. You have to exactly match the name. So pivot table 2. And you can tell where the pivot table is starting from. So it's starting from A1, right? So you can just say that pivot table is starting from A1. So you can say A1, right? And then which column do you want to look the value from? So that column is your country. So you want to match the value from country. And so you're going to write country. And the next, you can either give the name of the country here, or you can just pick, if it is already here, then you can pick the name here. But obviously, this needs to match the value there. So if you write China with the small c here, it's not going to match there. So you're going to make sure that these match. And so yeah. So this is just you getting the average of China, right? But the whole formula was average of China minus average of distribution divided by your standard deviation. So this and yeah, and so minus your average of distribution that you can autom pick up from here. So you don't need to put the whole get pivot data formula. You can just pick the average from here. And so I'm going to keep it constant because I'm going to drag the formula for other countries also. So I don't want to change this value because this remains constant. And that divided by your standard deviation. And again, for standard deviation, I'm going to keep this value constant. So to keep the value constant, like both the column and the row, you need to put a dollar sign. So a dollar sign before just the column number will keep the column constant, and a dollar sign before row number will keep the row constant. But if you have it for both, then it is going to keep that specific cell constant. So that is your z-score. And then simply for percentile, you can use the formula normal dot s dot distribution, and this is going to just for if you give it a z-score value, it's going to give you the percentile. And this is 99.98 percentile, and that makes sense because if you go here, you see um, China and United States are the top two countries, right? So um, and uh, and if you also see here, the z-score is 3.53, right? And you know within two z's, Where was that? Yeah, within these two minus 2 to 2z, 95% of the values fall. So it makes sense that it's 99, more than 99 percentile. And so you can drag then this for rest of the countries. Just make sure that the country's name match, right? Obviously. And your percentile. So, yeah. So this one is Germany is 0.57 from your mean, is 0.57 z value. So it would be 71.6. So, if you come here, it's going to be yeah, it's going to be, somewhere here 0.175, 0.5, and that would cover your almost 71 percentile. And because obviously you're starting from here, so this is 50, and obviously it doesn't move linearly because you see the curve up there, so it doesn't move linearly. So by here you will have 75, 71 percentile, and for Ukraine it's minus, so that means it's falling on the other side of the mean, so it's falling somewhere here. That's why it's less than 50, your percentile. And then United States of America is the top one, and it's 11.46, which you come here by 3Z scores, you are already at 100%. So that's why it is. And it makes sense because your United States of America is at the top. And so, yeah, it's here at the top. So it makes sense that why it is at the top. So yeah, so this was the overview of our um, in-class practice number 5. I hope this recording was useful. It provides a good like this exercise will provide you good insight into how to, like create summary statistics and then how to use them for uh doing some normal distribution analysis. One thing that you want to keep in mind is that it's not necessary that our distribution is normal. But we are just calculating these statistics assuming that our um distribution is normal. So you want to keep that in mind, um, because it makes calculations easier and there are ways to calculate. Because if the distribution is not normal, then it makes everything complicated. So I hope this was helpful, and I'll see you for next week, uh, hopefully. Thank you and bye.